Hello everyone. Want to talk now about the T-SQL, the Transact SQL that you'll use to create the tables that are addendum to assignment number 4. And those tables are the fact table, everything based upon the fact table here, SALE, S-A-L-E, and the normalized snowflake dimension tables here, region, state, city, and store, which you didn't have from assignment number 4, and including the time dimension table. Now, I do want to say one thing. I modified, since the last video, I modified the time table here, the time entity, to reflect some functions that we can easily use in Microsoft SQL Server, and also to make sure that the data types are they have some similarities. And so instead of in MySQL now this is MySQL Workbench. I'll also show you the difference between MySQL and SQL Server. Time ID, int data type, that's going to be fine. And let me just do a quick comparison here. Here's going to be SQL Server, and I'm going to bring you to SQL Server right away. Here we go. Okay. So, and you'll see this twice. So here's the time table, the definition of that table in SQL Server. Here in MySQL Workbench, for MySQL, it's similar but a bit different. I used for month, I said char3, and I'm changing that so that we can use some intrinsic functions for dates in T-SQL, in Microsoft SQL Server. So I modified time ID is going to be an int. It's the same here in SQL Server. Okay. There is no year date data type in SQL Server, so we have to make that a small int, which can handle, though, 4-digit years. So instead of making an int, we're going to make it a 2-byte integer, a small int, rather than a 4-byte integer, an int. So here in time ID, it's a 4-byte integer. So we're wasting 2 extra bytes because we don't need it in time year, because all we're going to do is store a 4-digit year, which can be handle in small int. But it's too large for tiny int. That's why we have to use a small int. However, in MySQL Workbench, if you look here to the right, you'll see that I have that as a year data type. Now, you could do that in MySQL, but you cannot do that in SQL Server. MySQL Workbench, we're having tiny int for quarter, same as in SQL Server. Tiny int for month, previously is varchar, or it was char3. We're not going to store it as a 3-character month. JAN for January, FEB for February, MAR for March, etc. We're going to store it as a tiny int, and I'll show you the functions that you can use in SQL Server. So month is going to be a tiny int. That's the same there. Week is going to be a tiny int, same in SQL Server. Day is going to be a tiny int, 1 through 7 in SQL Server as well. Here, MySQL is going to be tiny int. Time is going to be a time data type. Now, SQL Server does have a time data type, but it doesn't have a year data type. MySQL, on the other hand, as you can look to the right here, has both a year data type and a time data type. And notes, of course, is going to be varchar 255. Okay, so here's what it looks like in MySQL Workbench. The design, and again, I'm showing it to you in MySQL Workbench because it's just easier to look at and communicate with your client or your boss rather than in SQL Server. However, I want to state again that the ERD must be created in SQL Server, not in MySQL Workbench. Okay. All right, so I'm going to just put this off to the side so that you can see the entire design there. Okay, now we have our data store, or if you synonymously, a data mart, which is just a small version of a data warehouse. And again, notice the fact table. The primary key is made up of foreign keys associated with their respective dimension tables. So product ID, store ID, contact ID, time ID. These are form the composite key, and they are also the foreign keys of their respective dimension tables. All right, let's go back to the T-SQL here, and I'm going only to discuss again the tables that we're going to be using that are different from assignment 4, and that is region, store, city, the modification of, or I should say the modified store table that did not have the city ID, and I'm going to show you that. Sale is the fact table, and time is another dimension table. Okay? All right, let's begin. So I'm going to start with region. I showed you here. You could take a look at the comments for time. We're going to come back to this, but we're going to start off with region. And I want to say one other thing. Notice that store is a child table to city, which is a child table to state, which is a child table to region. And of course, store is also parent table to sale. So what we have to do, what we have to do in the original design of A4, we have to make sure that we get these in order. So right after the table order in assignment number 4, right after the table order, remember, it's a keyword there, so you have to put it in brackets. We're going to create the region table. Okay, there's a region table right there. And I indicated it's going to be a char 1. We could have made it a pseudo enumeration data type. We're just going to leave it as char 1 for 5 values, north, east, south, west, and central, only permitting one character, N, E, S, W, or C. There's our, you could pause that, but that's the create statement for region, which is a parent table for state, as you can see here in our design. So next what we'll go to is state. Now notice state has a foreign key of region ID. So we'll go here to state and show you the foreign key. Okay, there's a design, state ID, tiny int, region ID, tiny int. Remember, it has to match identically. State name, char 2. It can be upper or lowercase. We're not concerned about that. State notes, notice the foreign key on delete cascade, on update cascade, but the foreign key is region ID. And region ID, as you can see, is right here in the state entity. Now we're going next to city. Now city is going to have the foreign key of state. And again, it has to match identically. Keeping it as a tiny int because it's 50 states, right? So we can use a tiny int, which only consumes 1 storage byte. City ID is going to be a small int because there are obviously more than 255 cities in the United States. So we have to make it the next largest data type, which is small int. By the way, don't forget, all of our tables are going to have a auto increment. Of course, not sale because it's a composite key, and these attributes are also foreign keys. So we can't make that. We can't make this composite key auto increment. Okay, so here's city. Foreign key is state ID, on delete cascade, on update cascade. Next we go to store. Now we had store in assignment number 4. The only thing that you have to add is this attribute here for city ID. And again, it has to match. Small int. Okay. Now, I did say unsigned, but remember in SQL Server, we cannot have an unsigned data type. We can have unsigned in MySQL, but T-SQL does not recognize the unsigned keyword. So we just have to make sure it's small int. Okay, so make sure you modify your store table to reflect that new city attribute. So city ID, and again, in the store table, city ID here is going to be the foreign key to the city ID in the city table. Okay, so we got region, state, city, and store. Now, moving on, we already have invoice, so we don't have to do invoice, right? So here's store. I just moved to invoice. We already have that. No need to change anything here. Remember in invoice, I just want to say one thing about invoice. Remember in invoice, we already had the store ID, right, which is the foreign key, and the order ID. But we already had store ID, so we don't need to modify that. Okay, so we have that already. Next is payment. We already have payment. Next is vendor. We already have vendor. Next is product. We already have product. We have product history. And again, if you want to review this, just go back to your assignment number 4. I'm only talking about the tables that are different from assignment number 4. Now, if you look at time, you see that time is a strong table. Time is a parent table to sale. So we need to put in time table, just like we need to put in region, state, city, and store before sale. We need to put the time entity in here before sale. So let's go to time. I already showed you time, but let's review it again. So here is our create statement for our time table. Time ID is an auto increment. Okay, time ID. And then we have time year is a small int, time quarter, tiny int, time month, tiny int, time week, tiny int, time day, tiny int. Time is going to be a time data type, and then time notes is varchar. I have some comments there you could take a look at as well too, of why we selected that, and the values that would be inserted. So for quarter is 1 through 4, for time month would be 1 through 12, for time week 1 through 52 weeks in a year. Time day is 1 through 7, and then the time data type in SQL Server is based on a 24-hour clock, just the same as it is in MySQL. Next, we go to sale. Now, remember, gang, I'm going to have to do sale in parts here, in snippets, because there's a lot going on. Number one, product ID, store ID, contact ID, the composite, essentially, of customer and sales rep, contact ID, and time ID all formulate the composite key, but they're also foreign keys. So take a look here. We'll do this in snippets. Here are the attributes: product ID, store ID, count ID, time ID. Remember, those have to match identically to their corresponding primary keys in their dimension tables. Then the additional attributes, we have a sale quantity, sale price, sale total, sale notes, and what constitutes the primary key. Remember, if it's more than one attribute, we just separate those attributes with commas. Then after that, we put a comma because now we have a constraint. Now we have to have, we're going to make this a unique, this constraint, the composite of product ID, store ID, contact ID, and time ID. Also, they are foreign keys. So we're going to say that we're going to make this a unique constraint. And so we're going to make sure that the combination of time, and it's really, I'm being a bit redundant here, to be honest with you. I'm being a bit redundant. I just did this to show you, again, how to make a unique index, but I'm being a bit redundant here because we already said when we say primary key is the combination of product ID, contact ID, time ID, and store ID, we really don't need this. Okay, we really don't need this because the primary key designation will automatically make it unique. Okay, this really is redundant right here. But let's look at our foreign keys. Okay, here are our foreign keys. We have 4 of them. Okay, foreign key number 1, or not necessarily in any particular order. I'm just saying here that time ID is a foreign key, and as a matter of fact, I don't have these in order. If you want to put these in order, that's fine. You don't have to. But the foreign key of sale time ID is a foreign key. You can pause that. All of these are on delete cascade, on update cascade. Contact ID is a foreign key. And the associated table is dbo.contact. For time, it's dbo.time. For store, it's dbo.store. Store ID is a foreign key. And finally, product ID is a foreign key. Okay? Now, after that, you can check your tables by just running this statement here. Select all from information_schema.tables to make sure that, in fact, they were created. However, that's only telling you that the tables were created, not necessarily that they were populated. So what you want to do is then use these statements to populate them and then do a select all on each table. Now, again, I'm not going to go over the tables that we did in Assignment 4. We did person in Assignment 4. And don't forget, again, to check, you would do a select all after the creation of that table, just to make sure there's data in there. We did sales rep. We did customer. We have this already. We did contact. So just review the videos for assignment number 4. We did order. We did region. Here we go. So after order, here is the data for our region table. Remember, there's only 5 values. C for central, N for north, E for east, S for south, and W for west. Make sure that you check that. Here's our data for state. And I just threw some values in there. So only 5 records are necessary. So you can pause that. Here's our values for city. Don't forget the state ID, because state ID is a foreign key, right? Here in the state table, region ID is a foreign key. So go back to the design. You can see the design in our learning management system, and just to compare what those entities include as far as attributes. Okay, here's for city. Make sure you check there's data in there. Finally, here's for store. Now we only have to have for store. Remember, for store, we only have to have 5 records. However, do not forget that city ID is now a foreign key, so we have to add the value there for city ID. Notice the first value, 2, 3, 4, 5, and 1, are the foreign keys in the store table, and those foreign keys reflect the primary key in the parent table of city ID. So city ID is a foreign key in the store table. And then finally, values for store. Here, my apologies. My apologies. Here are the values for store, and here you do the select statement for store. Okay, right there. Do that select statement. We already have invoice. We did that from assignment number 4. You would check the data like that. Select all from DBO invoice. We have vendor. We have product. We have order line. We have payment. We have product history. Now, here are data for time. Notice the data. We don't need data for time ID. We don't need data for time ID because it is an auto increment primary key. So all we have to do is add values for time year, time quarter, time month, time week, time day, time, TIM_time, time notes, and there's the values there. Notice that for year, quarter, month, and week and day, they're all integers. And I gave you those values. Look at the top at the create statement, and it'll show you what permissible values there are. For instance, time quarter is 1 through 4, time month 1 through 12, time week 1 through 52, and time day 1 through 7. Now here are the original dates, just to show you. So if you take a look at the original dates there, and this is how I parsed the data to get the values here. Okay, here's the original dates, and I use the date part function with the following arguments: Q for quarter, M for month, WW for week, and DW for day. And that will give you it'll return integer values. I highly encourage you to research these following functions. Date part is a function, date name is a function, and everything is determined based upon setting the value of date first. Now, what that means is, what is the first day of the week? By default, set date first 7 means the first day of the week is a Sunday. And that's the default, by the way, for United States in English. That's the way SQL Server set it up. So the default first day is Sunday, and we set that to 7. If we want the default first day to be Monday, we would do set date first 1, and that would give us that value. Okay? All right. Now we just do a select all on time to make sure we have these values in there and they're correct. Again, you can pause that to see what it returns. Select all from dbo.time. And now here is the data for sale. So sale is right here again. As you can see, the foreign keys are product ID, store ID, contact ID, and time ID, in addition to its own attributes of sale quantity, sale price, sale total, and sale notes. So here's some data for sale. Okay, now remember, gang, that according to, I only put some dummy data in here. I didn't put all the data, but in your requirements, there should be at least 25 unique records in the sale table. So here I gave you a start. Make sure that you put in the correct data for the rest of the records. You need 25 unique records in the sale table. Okay, this is only a start, so you need to make more data. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You need to add 14 more records to get full credit for the sale table. All right, you could check here, dbo.sale. And now here is sales rep history. We already did this, so I'm not going to go through that again. By the way, the phone table, if it's missing from the last video's assignment 4, you must have them. There's a data right there. You could use that data. Yes, I get bored just like you do, so I have to amuse myself with some comments there. Feel free to use those or others, but you must have 5 records in the phone table. There's your 5 records. Okay? All right, gang, that's everything. And when you complete it, you would populate it by just copying everything here. And what you would do then is copy all your data, copy all your create and populate statements. Okay? And then what you would do, just copy that and go into SQL Server, paste it, and then run it. See if it works. See if there's any errors. And hopefully there are none. You can see that I did a select all in each table, and that each one returned data for each one of those tables. Okay? All right, gang, if you have any questions, please post them to the discussion board or send me an email. What is next on the agenda is our T-SQL statements for assignment number 5 using remote labs. So we're doing store procedures and trigger, and we're going to include the extra credit as well too. All right, see you in another video.